We're asked to evaluate the definite integral. I've already graphed the integrand function f of x equals 3 times the square root of x on the right over the interval of integration, which is from 2 to 5. Notice how the function is non-negative over this interval, which means the value of the def integral is equal to the area bounded by the function in the x-axis over this closed interval. To evaluate the definite integral, we need to determine big F of b minus big F of a, where big F is the antiderivative of the integrand function, and b is 5 and a is 2. Before we determine the antiderivative, though, we do need to write the square root of x using a rational exponent, where because the exponent on x is 1 under the square root, and because the index for a square root is 2, the integral is equal to the integral from 2 to 5 of 3x to the power of 1/2. And now we can determine the antiderivative using the power rule of integration shown below. The antiderivative is equal to 3 times x to the power of 1/2 plus 1, which is 3/2, divided by 3/2. And now let's simplify the integrand function. Dividing by 3/2 is equivalent to multiplying by the reciprocal of 2/3, which gives us 3 times 2/3 times x to the power of 3/2. Notice how we can simplify here. There's 1, 3, and 3 here and here, where 3 divided by 3 simplifies to 1. The antiderivative simplifies to 2x to the power of 3/2. Now if we wanted to, we could factor out the 2. I'm going to go ahead and leave it, and now we'll find big F of 5 minus big F of 2. So we first substitute 5 for x, which gives us 2 times 5 raised to the power of 3/2, minus, for big F of 2, we substitute 2 for x, which gives us 2 times 2 raised to the power of 3/2. Notice both of these products have a common factor of 2, so let's write the exact value as 2 times the quantity 5 to the 3/2 minus 2 to the 3/2. And now let's go to the calculator and get our decimal approximation to 4 decimal places. Which is approximately 16.7038. Which again, because the function is non-negative over the closed interval from 2 to 5, the shaded area below the graph is approximately 16.7038 square units. Let's also verify this result using the function integration tool on the TI-84. To do this, press Math, Option 9 for function integration, enter the lower limit of 2, right arrow, enter the upper limit of 5, right arrow, and now we enter the integrand function in either form. I'm going to enter 3 second x squared for the square root, x, right arrow, and then x for differential x, and then press enter. And we do get the same result, verifying our work is correct. I hope you found this helpful.